Let us continue our discussion here for the paper. Now, after describing everything, they have 8 automata, okay, for the specifications, 8 automata, and the final automaton is composed of 57 states. You can check these 8 specifications, 1, 2, 3, 4, 5, 6, 7, 8. You can check them. In order to see the full system using SuperMecha, you can go to the analyzer and then you can go here and right click and you can synchronize. We will have this one. Okay, as you could see, we are having a plant that consists of 67. We are having here 95 transitions, and we are having 67 states. Okay, as you could see, it's a very big plant, very large plant. Okay, however, this is not the one mentioned here, because here he is working with the supervisor. It is not just the supervisor is not just a parallel composition. No, if I'm trying to get the supervisor, I will select the automata, the plans, and the requirements. Right click, and then I will synthesize them for a non-blocking and controllable supervisor. This supervisor is what he mentioned, that has 57 states and 85 transitions. Okay, 57 states and 85 transitions. Unfortunately, he did not, of course, due to size or due to the space restrictions. As you could see, the supervisor is very huge. It's so difficult for him to describe or visualize 57 states. That's why in the paper he is referring to this link. However, I tried this link myself. I don't think it's active. You can try it, or you can request the author directly to get you the data. Now, the discussion for the output is provided here, the implementation. By the way, the output was not perfect. The output was not perfect, and it suffered some disadvantages. Okay, first of all, he tried to define what's so-called a deterministic supervisor. Okay, this means that if it is deterministic, that it does not contain any state from which the end event and another different controllable event are both enabled. Okay, he is mentioning this to be an error. Okay, and this error is immediate by simple inspection. I will explain this error now, or I will clarify it, or I will spot it and identify it in this example. And he is telling us if S is not a deterministic, a new specification must be introduced. Okay, another issue that could occur or could rise, that the automaton, or another deficiency, the automaton could also include states from which 2 or more controllable events are both enabled. Okay, in this case, he will call this a choice. And it's not a problem for him. Simply, this implies that the system can select among these two choices. Okay, we can simply, for the PLC controller, select any one of these two choices. For the case study, the automaton had 2 non-deterministic states, and it didn't have any problem with the choices. And they introduced a new specification. Unfortunately, the new specifications are not listed in this paper, and it is mentioned in the web page. However, we could try to inspect this problem. Okay, it will be difficult to inspect it visually, because we are working with 57 states. For instance, if you get this to the editor and try to have a look, it will be so difficult to spot what's meant by non-determinism. Again, non-determinism was when from a specific again, non-determinism means that namely that some state will have the end event and another different controllable event enabled. This is the non-determinism. Okay, it is so difficult to spot this from this figure. Okay, so the workaround is that we will export this automaton. Okay, let us go again to the analyzer. This was the supervisor. I will export it. We are having several formats, but I will export it to an XML format. Okay. I have exported that. See how to get it. From the desktop, from the downloads, supervisor. Here is it. Okay. As you could see now, we are having here the states, but what is really important here are the events. The end event is labeled 0. Okay. The controllable events are events number 5 and number 6. And we are having events 11 and 12. So we will look for any state from which, in addition to the event 0, events 5, 6, 11, 12 are available. Okay? These are the list of transitions. Okay? And as you remember, we had many dozens of transitions. It seems somehow difficult. However, the idea here is that the states are ordered. Okay? So for instance, for 0, state 0, we have only one transition out of 0. So we don't have a problem neither with 0 or 1 or 2. For 2, we can think that it may have a problem. However, it has 4 and 1, and both of them are controllable, so there is no problem. The problem if there is something else other than the 0. Okay? So 2 does not have a 0 at all. 3 does not have a 0. Okay, the 0 here is available for 6. However, we have only 1 6, have only 1 7, 1 8, and 9. There are no zeros. 9. Okay, we can work the opposite. This is the 0 and 11. However, we are having only 1 11, 0 and 12, only 1 12, only 1 13 with the 0. The 0 occurs with the 16, only 1 16, 1 17. Okay, 1 18, 1 19 with 0. Or 219. We are having 0 and 11. This is a problem here. For the 19. For the 19, we are having an event 0 and an 11, and the 11 is a controllable event, so this is a problem. Okay, he mentioned having two non-deterministic problems here. Okay, what else? Also with the 20. For the 19 and for the 20. 0, 11, 0, 11. These are the two problems. We will not find similar problems again. Okay? For the 19 and for the 20. So, for instance, what else here? 0 from 24, only once. 0 from 25, only once. 26 once, 27 once. 0 once from 32. 0 once from 33. There are no problems here. Okay. You can verify it yourself. 38, 39 on 0, 40, 41, 43. Okay. I don't think we'll find any more zeros with a problem. Okay, so we have spotted the problem that he mentioned. Unfortunately, he did not clarify how to obtain the specification to eliminate this or S dash. However, I believe the whole idea for this paper is clear right now after reviewing this video. Thank you very much for your attention.